Hello, good morning everyone. I hope all of you is healthy and happy. So today we are going to continue our lesson. Last week we already learned about set. So today we are going to continue about sequences and series. Okay. So after today's lesson, I hope all of you will be able to identify arithmetic and geometric sequences, and you are also be able to identify arithmetic and geometric series. So today's topic will be a bit a lot. So about sequence, we are going to learn about arithmetic and geometric sequence. And the same for series, we are going to learn about arithmetic and geometric series. But in geometric series, we are going to continue to study about infinite geometric series and to see which one is convergent and which one is divergent. So let's start our lesson today. First, we are going to learn about what is a sequence. Has any of you ever learned or ever heard about sequence? What is sequence? Okay, Anna, you want to answer? Yeah. Okay. That's really good. So, sequence is defined as an ordered list of numbers that follow a specific rule or patterns. So, each number is called a term, and the position of each term is matter. And the pattern or the or the rule determines how the terms are formed and relate to each other. So we can write a sequence like this. Okay, you can see on the screen. U sub 1 is the first term. U sub 2 is the second term, and U sub 3 is the next term, and so on until U sub n. Okay, so n is represent the term at the end position. Okay, so what is the sample of the sequence? So you may take a look at the screen. Okay, on the screen, I already write the example using matchsticks. So imagine you are arranging matchstick into rows. The first row has two matchsticks, and the second has four, and the third has six, and the fourth has eight. So you have sequence two, four, six, and eight. Okay, can any of you guess how many matchstick will be in the next row? Okay, Christoph, you want to answer? Okay, that's right. The answer is 10. Let's see. Okay, so in this sequence, each term is increased by 2. So we already know this rule is to add 2 to the previous term to get the next one. The first term is 2, and the second term is 4, and the third term is 6, and so on. So the term after 8 is 8 plus 2, so it's equals to 10. Okay, so a sequence can follow all kind of the rules, some simple, some more complex. And in this lesson, we are going to focus only two important types. There are arithmetic sequence and geometric sequences. Okay, so the first we are going to learn about arithmetic sequences. So what is definition of arithmetic sequences? So arithmetic sequence is defined as a sequence in which the difference between two consecutive terms is always constant. The constant value is called common difference, and we are going to represent it with the letter D. So in other words, in arithmetic sequence, you get one term to the next one by always adding or subtracting the same number. The position of each term matters, and knowing D and the first term is enough for us to find any term in the sequence. So for example, you can see on the screen, consider the sequence 1, 3, 5, and 7. So to find the next term, we can just keep adding the previous term with 2. That means terms after 7 are 9, 11, 13, and so on. Okay, so this is not kind of long sequence. So what if I want you to find the fifth term of these sequences? How will you do it? Okay, it's going to be difficult, right? Do we really keep adding two and two, it will take really a long time. It will take forever. So that's exactly why we need to use arithmetic sequence formula. So the arithmetic sequence formula is U sub n equals to A plus n minus 1 times D. So A represents the first term, the n represents the position of the term, and D represents the common difference. So U sub n is which term we are going to find. Okay, so let's move to the example. Okay, so consider okay, in this, I want you to find it first. So find the 20 term of the sequence 5, 9, 13, 17, and so on. Okay, so if we are going to find the 20 term, step 1, we need to identify the value. So the first term is 5. The common difference is 5 minus is 9 minus 5, which is equal to 4, and the n is equals to 20. So after that, we are going to apply the formula we already run. So, okay, after operating it like this, we already got the 20 term of this sequence. So the 20 term of this sequence is 81. Okay. Do you understand, guys? Okay. If you understand, we are going to move to the next topic. Okay, the next is about geometric sequence. So geometric sequence is defined as a sequence in which term is obtained by multiplying the previous term by a fixed non-zero number. So in other words, in geometric sequence, instead of adding the constant like in arithmetic, we multiply the each constant each time. The position of each term still matters, and knowing the R or the common ratio or the multiplier and the first term is enough to find any term in this sequence. So the fixed multiplier is called common ratio, or we are going to represent it with the letter R, I mean. So, for example, let's consider the sequence 1, 3, 9, and 27. So, okay, from this sequence, we already find the pattern. So each term is multiplied by 3 to get to the next one. So if we want to find the nth term of the geometric sequence, we can use this formula. So U sub n is equals to A times R to the power of n minus 1, where the un is the n term or the term we want to find, and a is the first term, and n is position of the term, and r is the common ratio. Okay, so let's move to the example. Okay, so let's find the third of the 13th term of the sequence 3, 6, 11, and 20 is I mean, let's find the 30th term of the 13th term of the sequence 3, 6, 12, and 24. Okay, so I want to ask you before I'm going to continue. So why this is called a geometric sequence? Has anyone know the answer? Yes, Anna? Okay, yeah, it's right. Okay, that's right. So if we want to find the next term, we need to multiply the previous term with which a number, which is here 3. 3 times 2 is 6. 6 times 2 is 12, and so on. So to answer this question, we need to identify the value. So in this sequence, the value is A equals to 3, R or the ratio equals to 6 divided by 3, which is equals to 2, and n equals to 13. So we can apply the formula and do the operation like this. So in the end, we got the 13th term is 12,288. Okay, so that's all about sequence. Okay, so we already learned about arithmetic and geometric sequence. So okay, I want to ask you something. So can one of you tell me what's the difference between arithmetic sequence and geometric sequence? All of you want to answer? Okay, that's good. So the core difference between arithmetic sequence and geometric sequence is arithmetic changed by addition. Meanwhile, the geometric sequence changed by multiplication. Okay, that's all about sequence. Now we are going to move to the next topic. Okay, the next topic is about series. So what is series? So series can be defined as a sum of the terms of sequence. A series can be written, I'm sorry, there is something wrong with this. Okay, so what I write there is S sub n equals to U sub 1 plus U sub 2 plus U sub 3 plus blah 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 and so on until U sub n. Or we can notate it in sigma notation, where S sub n is called a partial sum, the sum of the first n terms in the series. So so this is what we are going to learn. So in sequence, we already know the sequence or the terms. And in this series, we are going to sum. We're going to keep adding the term of the sequence. So for example, we have the sequence 2, 4, 6, 8, and 10. Okay, the corresponding series or the sum of these terms is S sub n equals to 2 plus 4 plus 6 plus 8 plus 10, which is equals to 30. Simple, right? Okay, but what if we have 100 terms or 1,000? You guys would want to add them one by one, and that will take a very, very long time. So we are going to use some formulas. Okay, so let's move to the arithmetic series first. So what is arithmetic series? Okay, simply an arithmetic series is defined as the sum of the terms of an arithmetic sequence, where each term increase or decrease by constant difference. Okay, so the sum formula of the arithmetic series is, okay, before we move to the sum formula, you need to you need to really understand about this arithmetic series. So in other words, an arithmetic series is what you get when you add all up of the terms of an arithmetic sequence. Because the terms follow a predictable pattern, we can find the total sum without adding every term individually. So we will get the formula of the arithmetic series, which is the formula is S sub n equals to n divided by 2 times a plus u sub n. Okay, so why we got this formula? So here is the intuition behind this formula. So imagine you will pairing up the first and the last term, and the second and to the second last, and so on. Each pair will always adds up to the same value, which is a plus u sub n. And there are n divided by 2 such pairs. So the total is n divided by 2 times a plus u sub n. Okay, okay. If you don't know the u sub n or the n terms, you can find it using uh, the arithmetic sequence formula that we already run earlier. So let's move to the Okay, I'm sorry. Let's move to the next example. Okay, so the example is find the sum of the first 15 terms of sequence 4, 7, 10, and 13. Okay, step 1, we need to verify the value. So the A is 4, the D is 7, subtract 4 equals 3, and the n is 15. And the step 2 is we need to apply the sum formula. So we, okay, we are, okay, this where we already got the formula. So we can just substitute it with the value that we already get. So the sum of the first term of this sequence is equals to 375. Okay, do you get it, guys? Okay, let's move to the geometric series. So simply, a geometric series is defined as the sum of the terms of geometric sequence where each term is obtained by multiplying the previous term by constant ratio. So in other words, geometric series is what you get when you add all the terms of a geometric sequence. Because the terms grow or shrink by a constant ratio, we can calculate all the sum using dedicate formula. So the formula of geometric series is L sub n equals to A times R to the power to the, I'm sorry, R. So the formula of geometric series is A times R to the power of n minus 1 divided by R minus 1, where R is not equals to 1. Okay, so we already know that A is the first term, N is the number of the term, and R is the ratio. So why we got this formula? From where we get this formula? So here it is. Okay, listen to me. So if you call the sum S, then multiply S by R, you get the shift version of the same sum. Most of the term cancel without when you subtract one from the other. So what you're left is with what you are left with gives you the formula, give you this formula. Okay. So let's move to the example. So the example is okay. To find the sum of the first six term of the sequence 2, 6, 18, and 54. So first, as always, we are going to verify the value. So the A is 2, the R is 3, and the N is 6. So after that, we can just apply the sum formula, and we are going to operate it like this. And we will going to get the sum of the first six term of this geometric series is equals to 728. Okay, that's all about geomet. Okay, that's all already are about geometric series and geometric series and arithmetic series. Okay, before we are going to continue, I want to ask you something. Is there okay? Have any of you thought can 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 a geometric sequence or arithmetic sequence shrunk or the longer you find the n term, the smaller the value. Does anyone have an answer? Okay, so can the value of the geometric sequence or arithmetic sequence is the n value is smaller than the n minus 1 value? Okay, that's right. Okay, so the value can grow or shrink. In arithmetic sequence, if you add it with minus number, you will get the smaller, and smaller value. The same goes for geometric series. If you add it with uh, one half or anything that one half or anything that are less than 1, you will get the smaller and smaller value. So after that, we're going to continue our topic to the infinite geometric series. Okay, have any of you asked, what if a geometric series, we keep adding the geometric series to the infinity? What will happen? So so this is what we are gonna get. So an infinite geometric series is defined as the sum of all terms on infinite geometric sequence that continues without end. So in other words, instead of stopping at n terms, what if we keep adding the terms forever? Can the sum ever reach a specific finite value, or will it be infinity? Infinity? Okay. Before we get the formula, let's has any of you know what is convergent and divergent? Okay, Christoph, you can answer. Okay, that's right. So a series is convergent if the sum across a specific finite value, and the series is divergent if the sum keeps growing without bound or just never settles at any fixed number. So whether an infinite geometric series converges or differs depends entirely on the value of R. If the absolute value of R is less than 1, each new term gets smaller, smaller, and smaller, approaching zero. The series converges and we can find the exact sum. And if the absolute value of R is greater or is greater is greater than 1 or less than -1, the terms don't shrink. They stay the same size. They are going to keep grow. The sum which just keep increase, and the series is diverged to the non-finite sum exists. So here is the formula. So S infinity equals A divided by 1 minus R. So where is this come from? So this come from the finite sum formula. When the absolute value of R less than 1, the term R to the power of n approaches 1 as n approaches infinity. So the formula simplifies to A divided by 1 minus R. So let's move to the example. Okay, find the sum of infinite geometric series. 8 plus 4 plus 2 plus 1 plus 1 half. So we are going to identify the value. A is 8 and the R is 1 half. So we are going to check the convergence. The absolute value of 1 half is 1 half. So the series is going to convert. So for the next step, we are going to apply the formula and we are going to operate it like this. And we got the S infinity is equals to 16. Okay, that's all about sequence and series. So what what do we get? What do we get after learning about sequence or series? Mungkin most of you may be think it is not really important. So why are we keep learning about this? What do we get? So honestly, more more and the most more than most people realize. Uh, this is going to be very, very benefit to us. So let's take a look at some fields where the concept of sequence and series is used every day. The fields are very vary. The first is the finance and economics, and architecture and engineering, the physics, biology, and population study, and even in music. Okay, you can use sequence and series in all of this field. So, so the first is about finance and economics. So, in this field, sequence and series are used to model how money grows over time, whether it's saving, investment, or loans. And in architecture and engineering, the sequence will help planning and design, especially when something needs increase by a fixed amount at each step. In Pisces, sequence and series appear whenever something changes by consistent factor like energy loss, wave pattern, or motion. And in biology and population studies, sequences are used to model how population, whether of people, animals, or microorganisms, grow or decline over time. And last, in music, sequences play a role, specifically in the relationship between musical notes and their frequency. Okay, let's take a look at the application. So here is the some example. So the first is a theater has a row of seats arranged so the first row has 20 seats, the second row has 23 seats, and the third row has 26 seats, and so on. So how many seats are in the 15th row? So we already know that this is an arithmetic sequence, so we all we need to do is verify the value. So the A is 20, the D is 3, and the N is 15. Okay, so the next step, we are going to apply the arithmetic sequence formula. So after we are going to operating like this, we will get the uh, the, the 15 row has 62 seats. Okay, next. Okay, so the next is Uyun and Jin Hyung decided to save money every month. So in the first month, they save 100 rupiah, and each month they doubles the amount they saved the previous month. So how much the total money have they saved after 8 months? So we already know this is going to be geometric series. So we are going to verify the value. We find the A is is 100, the R is 2 because it's they keep doubling it, and the N is 6. So we are going to apply the geometric series formula, and we are going to get okay, we are going to get the after 6 months, Uyun and Jin will have saved a total of 6,300,000 rupiah. Okay, that's all about the lesson today. I hope you already have a good explanation about series and sequence. Let's meet again in the next week. Don't forget to study at home and do your homework. I will upload it in Google Classroom and e-learning. So stay tuned and goodbye, guys. Thank you for today.